So I think we're live.
Yes.
Good morning, everybody. I'm checking
Good morning.
if everyone is coming online. Yes, we have people waiting. Let me just check if it's fully live and people are online. Yeah, we got people coming in the room. 10:20. I'm gonna start with a few words in French. Welcome our guests. Bienvenue tout le monde. À ceux qui nous arrivent de Twitter, de Facebook, de vos emails que vous avez reçus, de vos liens que vous aviez enregistrés auparavant. C'est aux sources du numérique, ASDN, notre rendez-vous mensuel proposé par Renaissance Numérique et Spin Tank pour échanger avec les auteurs de livres qui traitent de sujets de société numérique. Dans la foulée de précédents ASDN qu'on a pu tenir dans les années précédentes, dans les dernières années, sur les sujets d'intelligence artificielle, il nous a semblé très intéressant d'accueillir Ernest Davis pour un premier ASDN en anglais, ce qui va demander à tout le monde, non sous-titré, mais on part du principe que vous êtes tous familiers de cela, et je suis sûr qu'Ernest fera un effort pour nous transmettre ces éléments de manière assez clé, autour de son livre Rebooting AI, qu'il a écrit avec Gary Marcus. Voilà, dont on note d'ailleurs la différence que l'intelligence artificielle n'arrive pas à harmoniser nos colorimétries chez Henri et moi, puisque nous avons le même livre, mais pas du tout la même couleur. Voilà. Alors que je pense que c'est strictement exactement le même, commandé chez le même éditeur, etc. Livre très intéressant sur la confiance dans l'intelligence artificielle et comment construire cette confiance. Welcome, Ernest. Welcome at ASDN, which doesn't translate well in English, but which is our monthly rendezvous with people who take the time to write books about important technology and digital society issues. We're very happy to have a discussion about your book that you wrote with Gary Marcus, and that is available, and that was published at Pantheon last year, if I'm not, maybe a little bit more than the year before.
2019.
2019, yes, yeah, 2019, about building artificial intelligence we can trust. Henri, un petit mot d'accueil complémentaire après mon traditionnel verbiage.
In English, so hello everyone. Hello Ernest, thanks for accepting our invitation to discuss about your book. We are very happy to have a discussion around AI and one type of AI that is at the heart of your book, which is deep learning, that you offer a large review and critique about deep learning and what type of issues does deep learning ask to anyone, and how we can go beyond deep learning and how we can build different type of AI and which are the foundation of that. And so we are very happy to welcome you and then have a discussion around those topics, as deep learning seems the starring AI technology of the days. You are one of those that say, well, maybe it's not the right way of building an AI we can trust. So we are very happy to welcome you.
Well, thanks very much for inviting me. Let me begin by apologizing for speaking in English, but I have no choice, I'm afraid. So I want to start by giving a quick overview, as quick as I can, of what's in the book that I wrote with Gary Marcus. So next slide. Can I see which slides are showing here? Yeah, good. Next slide. Next slide. Good. So AI has had a number of what I would call marquee successes. That is to say, successes that seem impressive and have gotten a lot of publicity, and particularly successes at games like backgammon, chess, Jeopardy, Go, where they currently beat the world champions. It's also had a number of important successes, practically important and impressive. So it's very good at reading print, at reading handwritten digits on checks, at transcribing speech, at searching the web. Machine translation between the major European languages and Chinese has gotten very good. Image tagging is quite good. And then there have been a number of disappointments. We were expecting that the self-driving cars would be on the streets by this time, and they are not to any extent. Chatbots are fairly useless. IBM thought that it could build on its success beating the Jeopardy game to create a whole collection of useful applications, particularly in health informatics. And in fact, there was just a news report yesterday that it's pretty much given up that effort. Next slide. And then there's been a tremendous amount of hype. For instance, this is a headline from 2 years ago in Newsweek. Robots can now read better than humans, putting millions of jobs at risk. And this is somewhat extreme, even for AI hype, and not that you see plenty of this. Of course, robots cannot read better than humans, and in fact, no jobs were at risk. Next slide. What the AI system that was actually being reported on could read a short text and find a phrase in the text which answered the question with some degree of a fair degree of accuracy. So if you gave it this text, Chloe and Alexander went for a walk. They both saw a dog in a tree. Alexander also saw a cat and pointed it out to Chloe. She went to pet the cat. It could answer the question, who went for a walk? Chloe and Alexander, because that's a phrase in the text. But it couldn't answer the question, what did Alexander see? And it couldn't, because those are not consecutive in the text. And it couldn't answer, was Chloe frightened by the cat, because it's not stated directly in the text. So no, the AIs cannot read better than humans or anything like as well as humans. Next slide. Now, there are many dangers in putting excessive trust in AI. And these have had practical and unfortunate effects. There have been a number of Tesla crashes of cars driven on autopilot, some fatal, because the drivers have put too much trust in the autopilot system. There have been cases where the police, in speaking to U.S. police, and speaking to trying to speak with drivers who were speaking Spanish, relied on Google Translate, and then the judge threw the case out of court because the translation was not accurate enough. There are many, many cases. You can find all number of jokes on the web where autocorrect has turned what people intended into something offensive or humorous. There is an iPhone app which will read your mail and automatically make an appointment in your calendar. And, when it works, it's good, but some fraction of the time it makes the appointment for some other day mentioned in the email. And then that's, you end up missing your appointment if you trust to it. Next slide. In general, there's a problem with all of these systems, as I'll discuss, are trained on a corpus of data, and they often don't generalize well past their training set. So, for instance, if you train a reading system on black and white, then it may not well work nearly as well if it sees print, which is white on black. If you have a self-driving car which is trained in one city, that can be unreliable when it's used in a different city, where things are, the streets and the city in general landscape looks different. Next slide. Slide. Let's see. AI programs can read and echo or reinforce social biases. So, for instance, a policing program may send police to neighborhoods where many arrests have been made in the past. That doesn't necessarily mean that that's the best, most effective place to send the police. Child services takes children away from poor parents. And on these, there are two particular books I recommend. One is Weapons of Mass Destruction by Cathy O'Neill, whom I quoted earlier, and the other is Automating Inequality by Virginia Eubanks. Next slide. Slide. Still not seeing the slide.
I can see the slide.
You can't see
You
the
can?
slide, Ernest.
No.
More issues
no.
with AI systems?
Okay, more issues. Okay, I'll just trust it there. Additional issues. AI systems can feed on their own output. Translation programs generate output and then use it for training their next generation. So this creates an echo chamber where errors keep on being repeated. AI systems can be gamed. For instance, if you have a system for grading essays automatically, it may reward long sentences and fancy words, and students learn to write that kind of sentence and that kind of text without actually putting together a coherent argument. AI systems can be given the wrong goals, and the results of that can be strange. Next slide. And then, of course, there is the problem that bad users may misuse AI. There are criminals who can use AI for cybercrime or cyber terrorism, or to generate fake news and deep fakes. And then there are governments who use AI for ever more prying surveillance and for smart weapons. Okay, so these are the matters of concern. Henri said I should talk a bit about deep learning. So let me give as quick an next slide. As quick an explanation of deep learning as I can. A deep learning system conceptually looks like there's an input layer where the problem comes in, and then there is an output layer where the answer comes out, and then there are various series of neuronal layers between them, and each little neuron in here, which is represented by a circle, does an extremely simple computation. And it's a two-stage process. The second stage, which is more fundamental, is actually doing its job. This is called inference. In inference, the problem is fed in at the input layer, and then then the system progresses left to right. Each neuron reads its input and does a little computation and creates an output and sends it on to the next neuron along the arrows. And how the computation is done is controlled by numerical weights, so to speak, on the arrows. And this somewhat resembles how the brain works at a very crude level. This is called a neural net precisely because originally it was designed to reflect what we know about the process, the operations of neurons in the brain. And this, before you can run inference, you have to train it. And the way you train it is you have a corpus example. So for instance, for machine translation, you have what are called bitexts, that is to say texts in both, say, French and English, corresponding texts. For image, if you want a system that will label an image, you give it a collection of images which have been labeled by people as to what they contain. And then the learning process sets weights so that it does well over your corpus. And the process used here, which I am not going to explain, actually does not at all resemble how the brain learns as far as anyone knows. So to some extent, but not to enormous extent, modeled on neuronal systems. Next slide. So what are the problems with deep learning? Well, first of all, it tends to be very data greedy, and you need data greedy. People can learn a new concept. If you show them a picture of a new animal, they know, they can recognize that animal, they can recognize pictures of that animal, they can speculate about characteristics of that animal. Deep learning systems require lots and lots of examples, thousands, even millions of examples to work well. The deep learning systems are opaque. And this is the large difference between deep learning and other types of computer programs. When when it gets the wrong answer, there's no way to know why. All that you can see is the set of weights, and they don't tell you anything meaningful about how the computation was done. Programs, deep learning systems can't be debugged. If a mistake is made or a collection of mistakes is made, there's no way of going and manually changing it as you would do with a standard computer program. Pretty much all you can do is you either change the set you're using to train it, or you can, experiment with how it's set up with the architecture. There are many different deep learning architectures, and see if that improves things. But there's no way of fixing individual problems. These systems are brittle. There is a whole industry in creating examples that trick deep learning systems. And you can have pictures that to a human eye, have a picture of a pig, let us say that to a human eye is just a picture of a pig, but the deep learning system will identify as an aircraft carrier or something. These deep learning systems come with no model of the situation at hand, and they don't, if you're given the text to read, they don't create any they don't build up any model of the narrative, and with no knowledge of the world. They don't understand how the world works, and it's very difficult. It's essentially impossible to build that kind of knowledge into a deep learning system. All you can do with a deep learning system is to train it. And in general, we found that people have found it generalizes in the wrong way. So for instance, in vision, it puts more of an emphasis on texture than on shape. Next slide. So I'm running out of time. Gary and I propose the following road to building AIs that can be trusted. The three most important components are: it has to include a large level of common sense knowledge and common sense reasoning. We want to use what we know about the human mind in designing AIs, and we need simply good principles from engineering. And the key takeaway, if there's one thing that I want to emphasize in this talk as a takeaway, it's that you should not think of an AI program as being sort of a strange person, a person with kind of odd gaps in its abilities. You think of it as a program. It is a complicated tool, and like other tools, has to be well engineered. Next slide. So common sense is the great gap in current AI. This is a picture from our article on the subject. Next slide. What is common sense? It's the basic knowledge of the world that children at a young age learn and master, that's generally too obvious to be worth writing down or teaching explicitly in school because everybody knows it. And most importantly, it's common to all of us. We take it for granted in speech that other people know it and we don't have to explain it. Next slide. So this includes as domains things like time, space, causality, physical interactions, theories of mind, human interactions, and so on. Everything you just assume that the next person on the street will know. Next slide. It's important, it's critical in many AI domains, including vision, language, robotics, understanding science, and interacting with computers. Next slide. As I say, we want to, Gary and I advocate that AI should incorporate what we know about what we've learned about the human mind from cognitive psychology, linguistics, and epistemology. Currently, it incorporates some of what, deep learning systems incorporate some of what we know about neuroscience, but mostly ignore these other areas of the cognitive science. So there's no silver bullet. There's no single solution to intelligence. You need representations of knowledge that are both symbolic and compositional. They are built of symbols and they can be composed into larger propositions. You need the system has to be able to deal with abstractions. It will need probably a substantial degree of innate knowledge. We have every reason to think that children are not, in fact, blank slates, that they come into the world with some basic knowledge of what to expect, built by evolution. That it can achieve understanding, which is building a model of the world, keeping track of individuals and keeping track of categories over time. So we are advocating that the direction to building AIs lies in substantial part in combining what we know about machine learning. We don't want to throw that out, but combining that with systems that deal directly and deeply with this kind of issue. Okay, thank you. And now I'm happy to discuss or take questions.
Thank you, Ernest, for your presentation, which capture almost what everything is in your books. What struck me when I read it is you're claiming for deep understanding rather than deep learning.
Right.
Can you elaborate about this, the opposition that you made between deep understanding and deep learning?
All right. Well, first of all, deep learning is the deep and deep learning just refers to having lots of layers, which in the original neural network systems were limited to 2 or 3 layers of neurons. There were technical improvements both in hardware and software. So deep learning systems now often have hundreds of layers, and that makes them much more powerful. So they are deep only in that sort of mathematical sense. They don't have a what we mean by deep understanding is a real grasp of how the world works, of how events are structured in time and in how objects are structured in space, how people interact. This is deep learning systems lack that to a startling degree. There's been a lot of publicity recently around the GPT-3 system and other language modeling systems, which generate very plausible looking text for pages and pages, but they don't actually understand a word of what they're doing. They just have learned patterns of text to supply, and they can't connect that. They have no connection between that and any kind of external reality. They're in the words of a recent paper, they are stochastic parrots. So not my phrase. This is what we're arguing. This is the gap that we're arguing in deep learning, and what we claim that AI should focus on.
And how do you explain that there's such a fascination around deep learning? Because at various points in the books, you say that AI efforts that are conducted today are referred to very high tolerance of error systems such as product recommendation. And so it seems that we have an illusory progress gap as we are focused on some recommendation system that seems very efficient, but in fact have a high level of error of tolerance, no?
Well, the reason that deep learning has gotten so much excitement is that it's been enormously successful in a number of domains. All these successes in games playing programs, many of the recent successes, a substantial part of the recent successes in natural systems are powered by deep learning. And at this point, AI systems that don't incorporate some degree of deep learning are very much the exception rather than the rule. And many practical AI systems are almost entirely powered by deep learning. So that's the reason that you're hearing so much about it. It's working much more effectively than any other technique that we currently have. The degree of accuracy depends, very much on the particular task at hand. Games playing programs produce moves that are better than any human being on the whole. The recommendation systems, recommendation is inherently a hard problem, right? All you have is what the person has bought in the past, and you come up with, the system certainly come up with egregious errors, but it's not clear, how well you could do even in principle on those.
Okay, and there's also one element that I like when I read the book is you talk about the obsession with building blank state machines that learns everything from scratch,
Right.
driven purely from data rather than from knowledge is a serious error. Can you elaborate about that?
Yeah, there is deep learning systems are trained on data, and as I said, it's very difficult to build what we know about the world into them. So, for instance, if you are training a deep learning system to make physical predictions from a video, you show it the first 5 seconds of a video, and you want it to predict what will happen later. Then in some simple situation, right, you have a tower of blocks, you want to predict whether the tower continues to stand or whether it falls over, it's unstable. So you would think, we know an awful lot about that problem from physics, and you would think an AI system in building an AI system, you would start by building that in. Or in natural language systems, we know a lot over millennia about how natural language works syntactically, semantically, and so on. And deep learning systems that do natural language systems throw all of that knowledge out and simply start by looking at the texts from scratch as if they were coming from Mars and had only the texts to look at and no previous knowledge. Now, that's true. That's largely true of deep learning systems. It's not entirely true of deep learning systems, but there is a bit of a fetish in some parts of the deep learning community to make that as true as possible. They feel that the more that a system can be built purely on learning, and the less that it can involve knowledge, prior knowledge, the better. There are some ways of building some degree of knowledge in deep learning systems, but there is a trend in parts of the deep learning community to reject that. And you feel that's seriously the wrong direction. You want to build as much knowledge as you can into it, and the focus should be on getting systems that can both learn and can use what we already know.
Okay, I would have many other questions, but I can let Nicolas ask some of questions.
Yeah, thank you, Henri. I have a question maybe more linked to the end of the book, because in some way what you propose is that you suggest that there's a big chiasm between the current expectations towards AI and the way we work together on focusing mainly on deep learning, which will not be able to to answer the expectation that we would put on AI. And in the end of the book, you say that we can build an AI we can trust that can have a broader impact in some way. Still, when I finished the book, I was somewhat skeptical about the high expectations that we can have around AI. And you say it might take a decade or a century, but the path doesn't seem very clear. So maybe is your goal to mainly deflate all the expectations, or the way to reduce this chiasm between expectations and reality? Is it to deflate expectations, or to make the reality of AI, will the reality of AI somewhat in some day meet the fantastic expectations that many people have been putting at this? I don't see how the balance, the chiasm can be reduced in your strategy. And if you are super ambitious about AI, or more proposing a more modest path compared to all the bubble that we've been seeing in the past few years.
Okay, well, the book had two purposes. The first was three purposes. The first, it was just to present a realistic view of.
And this is really fantastic. Yes.
A realistic view of where AI is now, and the second is to, as you say, deflate expectations of where it's likely to be in the very near future, in the next 10 years, let's say. Looking further, it's very difficult to predict what will be, what can be accomplished, and what will be accomplished. If you take any time in the last 2 centuries and ask for, what the predictions were for, the technological state 50 years hence, they were in, the accuracy is not very great, and no reason to think that we're in a better position to do that now. So I wouldn't have any great confidence in predictions for the future. Some of the extreme claims that have been made for AI, the AIs will, solve humanity's great problems, and people have made these claims. Those seem to me really way off the mark, because it's not God, and it's not going to be God, and it's not going to, and to the extent that our problems are features of our society and our political system, it's not going to enable us to fix those either. That has to be done a different way. Now, what the capacities of AI will be 50 years hence, I would not venture to predict. It seems to us that it seemed to us that there is a great deal to be gained in many ways, and with realistic expectations over a fairly realistic timeline. There's a great deal to be gained from having powerful AI systems, potentially, and that the way to get beyond the limitations of deep learning is along the lines we suggest. Exactly how far that will get us, I wouldn't want to predict. The book includes some hopeful scenarios, but I wouldn't have enormous confidence in those.
To complement Nicolas' questions, at the end of the book, I was asking myself, okay, I can understand your critics against the deep learning approach, which is very well elaborated in your books. Then you have some recommendations on how to build AI we can trust, and it's mainly heavily set up on cognition approach, but I was a bit skeptical about this type of a path, because we've learned from the past that it's very complex to build AI on type of foundations. I fully understand that that's the right way of doing things, but how can you cope with the fact that those success in deep learning has put some questions around those cognitive approach, and how can we revitate them so that there's a budget and research project that start to include those type of approach. And you mentioned that in this perspective that there might be some combination between deep learning and other AI techniques. Is that the right way of doing things, or it's just one possibility?
I think that's a promising direction. There are any number of people who are working. It's in a very active research area in so-called neurosymbolic systems that combine deep learning with symbolic reasoning, and I think it's promising. I don't know of any startling successes for that methodology. It's worth pointing out also that many of the actual successes of deep learning, in fact, build in some degree of AI systems, in fact, build in some degree of techniques beyond deep learning. Pardon me. And that goes from vision systems that at least minimally know that, whether a cat appears in the upper right-hand corner or the lower left-hand corner of the image doesn't matter to whether it's a cat. This is an old technique known as convolutional neural networks. To systems like, if you ask a question to Google, what day is it today? How much is 1.36 rupees in France? It has a whole collection of techniques that it's drawing on. It's certainly not powered for that kind of thing by deep learning, and so the in practice, this pure data-driven deep learning approach is not by any means all that's going on in practical AI systems.
And I do also understand that common sense is fundamental elements to build an AI we can trust. But how can you build a machine that has common sense? Can you just give us some example of how we can approach common sense with the machine?
Well, that's a really tough problem. I've been doing my own approach to symbolic reasoning symbolic approaches to common sense reasoning for my whole research lifetime, and it's very hard. For a long time it was very few people were interested in it. It's become a somewhat hot topic lately. It's going to have to be, I think, some combination of learning from all kinds of sources, from interacting with the world, from videos, from text, built-in knowledge, knowledge collected from people. I certainly don't know what the solution to that problem is going to be. But I think it has to be, I think until we solve the problem, we're not going to have really powerful AI.
I may also have another question, and which is about in the title, which is how can we trust a machine as human?
How can we as humans trust a machine?
Yes.
Well, I mean, we do to a very large extent.
But the machines we are talking about,
and we are very disappointed when when the grid goes down in Texas and people with disastrous effects. We put enormous trust in machines, and our argument is we put trust in machines, and most of the time, often it's justified trust because the machines, because we understand how they work and they have been solidly engineered and tested, and they have built in, their backups in case for failures and so on. So trust in machines is a characteristic of our civilization. What we have to make sure is that the trust is largely merited for AI programs, and at the moment, that's often not the case.
Yes. And in this perspective, do you think that that transparency that is claimed all over the world about AI and the way it is built, which data is used, how it is trained, would be enough so that we can develop trust in some AI machine?
It's important. It's not in itself enough. No. Just having transparency about how it works and how it was trained and so on is not going to get you a reliable system.
Okay.
I guess if my driverless car has been trained transparently, but still gets wrong about the situation because it was not trained properly or could not react to the wrong situation, I'm not going to trust it more than if it was opaque but nicely trained. So I guess it's a combination of factors. It's a little bit puzzling because this debate about AI is in a moment where there has been a lot of expectations and a lot of exaggeration about its potential, and we see, and your book is absolutely crucial about layering down all of this matter and getting real about what the potential of AI today is. But there's still the exit way and the strategy seems extremely ambitious to have a common sense AI, to have a broad understanding in artificial intelligence. And it is a little bit like the path that you're proposing. And my understanding, I'm not a specialist about AI, but in the understanding that I have, the path that you're proposing is in somewhat impossible for artificial intelligence, or nearly impossible in some way. And that the right path about AI would be to focus on some very narrow knowledge fields or applications, and that the big and that all the conditions that you list about building AI that we can trust are making it quite impossible to really, in the end, build an AI we can trust. And that's the impression of a reader. Would you confirm that in some way, or is there any mixed way of getting out of only character recognition and pattern recognition and image recognition and stuff like that are already very interesting applications? Or can we mix deep learning and its interest with and how can we? The question is not easy, I guess, to answer.
It's not easy. I mean, but there certainly exist AI programs that deal shallowly with broad characteristics. A translation program will translate a text about whatever you want. Now, it can't do anything except translate the text. But you're not. But in one dimension, you're dealing with anything that can be described in language, which is pretty broad. So you're not. you know, the robots that are on Mars are, you know, very limited in what they can do, but, you know, are operating on their own necessarily to a large degree, and are dealing with everything that they have to confront, which on Mars is a limited and predictable collection of things. So I don't see that AI is necessarily limited either in task or in subject matter, so to speak. You know, we don't have any AI programs yet that I know of which can deal, you know, can carry out lots of tasks in, you know, we have broad capacities across broad domains, but I don't see an inherent reason why we couldn't get there. And I'm optimistic that we can get there. On the other hand, you know, until it's done, you can't be sure that it's doable.
It's a good scientific approach. I agree on that. And
and it's almost never, you can almost never be sure that it isn't doable.
That's a contrast. I want to understand, but yeah, I think the progress in typically in translation has been quite tremendous by getting out of a very strict deep learning AI method. So I think there might be some mixed approaches or some not only narrow but broad understanding that can get a little bit better, I guess.
Yeah, translation approaches have been powered by learning methods, you know, since they've been successful at all. But deep learning, you know, they were, and now they have a large deep learning component. But it's not it's not. They're not even now. They are not entirely powered by deep learning, and the deep learning component is only, I don't know, 4 or 5 years old. Before that, they were using other learning methods and worked, you know, a little less, somewhat less well, but quite well. You know, it seems to me that translation in particular is an area where there should be the potential for incorporating different kinds of knowledge, and you know, I think more could be done in that direction, even in the current state of things.
Yeah, we have a question on the chat from the audience coming about driverless cars, because Jessica, who asks that in your introduction you mentioned some disappointments related to AI developments, took the example of driverless cars, which is fully developed in the book. The question of Jessica is the limitation of the advances not due to issues of legal responsibilities or lack of legal framework, rather than technical feasibility? Well, I could have the answer, but I guess that you...
Well, it's a pity Gary isn't here because he's much more expert on that than I am. There are still large technical issues. As my understanding is, there's still large technical issues in driverless cars. That if you driverless cars are, you know, very good in predictable situations and not at all good in unpredictable situations. So, for instance, if take an extreme example, you know, if the car is driving up to a bridge and the bridge has in fact collapsed in front of it, well, that probably wasn't in its training set and probably doesn't realize what to do. So, and then, you know, anything anything that sort of blows across the road, if something's blowing across the road or is on the road, and the sensing systems are not all that good at distinguishing, where in three-dimensional space an object is, and if it's an unusual object, then they may not know how to respond, and they can't simply stop every time, because you don't want them to stop every time a paper bag comes within view. So I'm not an expert in this area, but my understanding is that the current state of the art, there's still serious technical issues to be overcome in terms of unusual events, which are not in fact that unusual. One of the features of AI problems is what's called long tail, which means that there are a lot of events, each of which individually is very rare, but the frequency that you're going to come up with some rare event is all too common.
In this perspective, I have in mind the same issue that arose in the finance, where they use a statistic distribution with long tail events that they say, well, it's a very low probability, and we have the same issues with deep learning, where we consider that there are events that don't occur with a low probability, and we say, well, we can trust this because there is no way these events will pop up, and we know that from the finance industry that sometimes it happens, and the similarity of those two approach of statistics in finance and in AI is, to me, something that I have always in mind when people say, well, it never happens,
Yeah, right. Yeah, well, any number of companies, well, some conspicuous companies lost their shirt in 2008 because of events that they considered too far-fetched to occur simultaneously. To some extent, one does, of course, need to ignore low probability events. If you're crossing the street, don't worry about the possibility that a meteor is going to hit you. But as I say, you can't ignore the long tail as a whole, because the likelihood of some unlikely events is real, and your ability to estimate, this is the connection with finance, your ability to estimate the probability of low probability events is rather poor, since you can't get a sample. So you have to rely on your model, and models are not good at that end of the spectrum. So yes, it's a serious problem for AI. I mean, you can't, again, at best, AIs are not going to be God. And if there's a limit to what kinds of problems can be solved, you can't put impossible requirements on AI. If AIs can do as well on ordinary, AIs are much worse than human beings at all kinds of tasks. They are, of course, much better at other tasks, but they're much worse at all kinds of tasks. And there we know that the problem can be solved because human beings do them. So that's where you want to, that's the gap that you want to meet.
I was when I read the book, I also asked myself if you were aware about the book of Julia, who set up a series, and the title of his book is AI Doesn't Exist.
No,
have you heard about
I didn't
this
know
book?
the book. No.
Maybe it's only
Gonna do this?
available in French because he is French, but it was quite provocative title.
Yes.
It was but it was when I read your book, I was it is very similar type of arguments that is provided by Julia and Gareth Marcus and you about the fact that we are fascinated by things that are just statistics and we don't understand that it's very good at narrow task. And the path towards a general intelligence seems, as you mentioned in your book, quite a long way.
Yeah, okay. I haven't seen AI. It doesn't exist, so I can't comment on it. I'll look for it.
Yes,
If you
it
recommend
was. It was very similar argument that both of you are using in your books, but it's not claiming about what you are proposing to redefine and rearticulate the cognitive approach of AI, which is not the type of thing he's discussing in his books, but about what deep learning is all about and what it can do and what it cannot do. It's quite similar in terms of critiques of deep learning.
Mm-hmm. Okay.
Nicolas, another questions? Or do we have questions from the audience?
Sorry, I was muted. There's a question from Daniel from the chat, which I think connects to your idea of developing common sense and mimicking the human brain or integrating knowledge and so on, which is which aspects of the human brain can we draw inspiration from to improve AI in the near future? Which is a broad question too. Another one.
That is a broad question. What we discuss in our book mostly is not brain science, but cognitive, science of the mind, cognitive psychology, linguistics, and to some extent epistemology, and what we're arguing for is that we want to create AI systems that are much more similar to those that have been proposed in the cognitive sciences. So you have some form of what's called mentalese. You have a symbolic representation of knowledge. Both of specifics, what your office looks like, the individuals that you happen to know, and of world knowledge generally, how relationships between objects and people and so on work, that you can deal with abstract concepts, that you can understand complex relationships between objects. So those are what we are advocating in terms of imitating the human mind. Now, if you're asking about brains specifically and what known features of the neuronal system we can adapt, then I don't know. I'm not an expert. I'm not at all an expert on the brain, and the neural network systems, the deep learning systems, are, as I said, modeled strongly on the brain in terms of carrying out activities like vision, much more weakly in terms of but to some extent in terms of so-called higher level cognition, like language understanding or like planning and so on. But my understanding is that, the relationship, the brain is itself not well understood at this point. And in particular, the way in which higher level cognition is implemented in the brain, so to speak, occurs in the brain, is poorly understood. So, so the answer is I don't know. In short, I've given as good an answer as I can.
Sorry, muted as usual. That's a very good answer. Anyway, another question by Paul is: should AI systems be, in the long term, banned from specific positions where it has to take critical decisions, such as warfare situations or critical hospital facilities or particular applications where, given the current state of AI, you would say we should ban them from taking critical decisions? Or do you think of
one has to evaluate each situation on its own. So, for instance, in a hospital facility, you can imagine a situation where something has to be done for a patient in faster than a doctor can be summoned. And in a certain sense, a pacemaker is making decisions constantly. Now, these are not AI driven, but a smart pacemaker, so to speak, might be able to make better decisions. So, so in some, I certainly wouldn't say that you want to necessarily bar AIs from making all critical decisions. I can't imagine any circumstance in which you want an AI to make the decision to go to war or have any significant input on the decision of whether to go to war. I say I can't imagine, and now I can't imagine, right? So the question is, we averted that nuclear war. I forget when it was, 30 years ago, 40 years ago. There was an incident where a Russian officer had to decide whether his country was under the Soviet at that time was under nuclear attack or not, and he realized that his equipment was misreporting they were not under nuclear attack, so he didn't respond. And if he had responded, the idea would have been catastrophic. The response would have been catastrophic. So certainly at this stage we want people making those decisions, not AIs making those decisions, presumably. And I would think that would be true for the foreseeable future. But in general, as I say, you have to consider each situation by itself, and you have to decide. You have to figure, what are the trade-offs? How reliable is your AI system? Being very pessimistic about that, as compared to giving it to people. Is it a realistic to have people in the loop and so on? So that would be my answer.
That's very nice. It makes me think of another application that you don't mention a lot or don't mention in the book, if I remember, which is art. Because we had
art.
welcome art.
Yeah, sure.
We had a festival a few years ago with digital art and so on, which is called Grow in Paris. And Mario Pingemann, I don't know if you know him, he's a German artist, and he tries to paint using general adversarial networks and training these networks with a lot of portraits, but classical portraits. And
right.
In this, he was trying to show how these deep learning systems were quite stupid and how they lacked knowledge, because when they wanted to reproduce another portrait, they didn't make a magnifique, nice 18th century portrait, but more like a bizarre, accidental Francis Bacon painting. And it was really nice because in some way it connects to one of the good topics of your books, which is the connection to knowledge and to the broader understanding of what you do. And it's nice to see an artist play with it, to showcase it in a very emotional way, and to see, okay, I have an accidental Francis Bacon. A machine can draw a Francis Bacon, but she has no idea what she's doing, that she's doing it. And you can feed a machine with tons and millions of 17th century or 18th century portraits, and it will produce a Francis Bacon. But it doesn't know, and it has no understanding of it. And it's better when it's Francis Bacon painting of Francis Bacon, knowing what he knows in some way.
Sure.
Made me think about it. This lack of broader knowledge and so on. I don't think we have many other questions. We have two questions maybe to finish with. The other question about the future of AI in the world of work. Do you see many applications of AI in the world of work, given what you've done, or do you think that there would be limitations in some way? And there's another question about the singularity concept, but I think maybe it's a bit out of focus for you. How do you think in of applying AI in the world of work?
Computer technology has completely revolutionized and overturned the world of work over the last 50 years. And I don't see any reason to suppose, it seems perfectly certain that AI programs will be used in many different ways in the workplace. Which specific jobs will be eliminated and what they'll be turned into is very hard to predict, and how it will work. Again, people were predicting 5-10 years ago that by this time large numbers of truck drivers and so on and taxi drivers and so on would have been displaced by self-driving cars. That hasn't happened yet. It could happen if the technology gets good enough. It seems to me certain that it will happen. AI, the impact of AI. Again, you want to think of AI as a tool, as a very powerful tool, rather than as a competing human being. So the precedents you want to think of are, let us say, the impact of word processing technology on all white collar applications, right? So the office computer and programs like Word and so on have revolutionized office technology. The ability to edit and create videos has revolutionized. There are lots of people who would never, there are many more people creating videos now to put on YouTube than were filming movies 50 years ago. It's the effects of AI are likely to be very extensive and quite hard to predict. I'm afraid that's not all that helpful, but I don't know what I can say more.
What you say in your book, I would say also that it's highly, you could consider that you will have less driverless cars, but more driverless carts in Amazon warehouses in some ways, where you have a very narrow and predictable and environment that doesn't require a broader understanding of and a reduction of long tail events that would come that could come.
Yeah, well, of course, places like Amazon manage to treat their workers so badly that it's cheaper to hire humans than to build robots,
Yeah.
and the humans have to find their ways around somewhat dangerous robots at the moment, rather than the other way around. Again, because that's cheaper to do.
Yeah. And there's also, I think, a big confusion in technology, and AI has sometimes replaced the whole world of technology, and or algorithm as a whole. Like when you say, especially in social issues, for example, when you say, we recently had big discussions about how Uber drivers or Deliveroo people delivering food at home are responding to algorithms, but they are usually not AI driven in many ways. They are just ways to optimize stuff and not understanding what AI. And maybe there's a lot of confusion. And when you talk about Watson and the hype and all the discourses about how AI will solve the world, sometimes there's been maybe a little bit of excess in marketing from technology companies in the past few years about
for sure,
AI hype.
Sure.
And maybe it added some confusion about the understanding of what AI strictly is, because the term is fantastic is like a path for technology.
Yeah, for sure. I mean, there's been enormous hype, driven by the companies and abetted by journalists who, on the one hand, don't necessarily understand the limitations, and on the second hand want a startling headline to draw clicks or sell copies. So you have to take what you read about AI with a lot of skepticism, and you have to, if you want to know what's going on, you have to look into it fairly carefully. And actually, in the book, we have some suggestions of questions you want to ask when you hear about some startling advance in AI or some startling effect of it.
Okay. Ernest, I think it's a very good phrase to finish with. And thank you for accepting this discussion with Nicola and I.
Well, thanks very much. This was very enjoyable.
Yes, and I recommend everyone to read this book, which is a very insightful reading for understanding deep learning and what can be done to overcome the limitation of deep learning. Thanks again, Ernest. Our next meeting will be on March 23, donc 23 mars, où on accueillera Alexandra Profizzi pour un livre qui s'appelle Le temps de l'ironie, comment Internet a réinventé l'authenticité. Et c'est Nicolas qui s'y collera avec le dé.
Merci à tous. Thank you very much.
Merci à tous.
Okay, thank you.
Have a good day.
And have a good day.
You too. Take care.
Thank you. Bye-bye.
Bye.
Yeah.